Alright, so this lesson is called medication, and what it is, it's algebra, but it's used in the context of medication. So the main skills that we're learning that are new are we're going to change units and substitute into relevant formulas. And then there are a few relevant formulas, but they will be given to you when we use them. Okay, so if the question requires you to use a relevant formula, they'll be given to you. So that will occur here as well. So like any time, you can pause, write this down, make sure you write this title, learning goal, and date. Okay, so here's the first example. A medicine has a concentration level of 200 milligrams per 500 mils. What would be the dosage rate for a medicine that is grams per milligram? Now there is actually a fraction. We've got grams over milliliters. Now the information we have is milligrams per 50 milliliters. So essentially we have to change this unit. Now to do that, we need to form a little conversion chart. So I'm going to put kilograms here, grams here, and milligrams here. Now this could easily be kiloliters, liters, and milliliters, but it is not in this case, but it'll work in the same way. Now I'm going to think of something. 1 kilogram, how many grams does it have? 1,000 grams. Many of you will know that. And kilo actually means 1,000. Okay? So if this is 1 kilogram, what do I have to do to get 1,000? I need to multiply it by 1,000. All right? And then the arrow, because it's forming that way, will go this way again, and we'll go multiply it by 1,000. And the reason for that is that 1 kilogram is 1,000 grams. All right? So to convert from kilograms to grams, we have to multiply by 1,000. Now, if that's the case, the opposite will be, what's the opposite of multiply 1,000? Divided by 1,000, okay? Divide it, I'm going to change my arrows a bit. Divided by 1,000, okay? Now, hopefully you're able to replicate that for an exam because it'll become very important, okay? With that in mind, what do we have to do to change 200 milligrams to grams? Well, we have to follow this path, which means that we have to divide by 1,000. So let's write that down. Actually, that's not part of it. I'll leave that there. So we're going to go 200 divided by 1,000 over 50 milligrams, okay? So we're going to pop that in our calculator. So your calculator will handle that no problem. So I'm going to go divided by 1,000 over 50. And I get the answer of 0.004, and the units are grams per milliliter. Okay? So this is all about conversion. If in your notes, what I really want to see is this in your books, because you will see it over and over again. And like I said, it could be liters and other sort of conversions. All right, example 2. So if you haven't finished that, just pause and rewind it. A patient is prescribed 1,000 milligrams of mild painkiller. The medication available contains 100 milligrams in 5 milliliters. Now, we're going to use this formula because that's what it says here. And here we go, is that strength required is in milligrams. So what's it prescribed? How much is it prescribed? Well, it's 1,000 milligrams. So we're going to write that down. So I'm going to write the formula. Volume required equals, what's the strength required? What's down here? It's 1,000. And it's in milligrams already, so we're good. What's the stock strength? It goes, well, what's available is what's in stock. So that's 100. So we're going to put that in. So that's the same as that. And now we're going to multiply by the volume of the stock. So this is volume. So volume is often in milliliters or liters. So times 5. And we're going to work that out. Now I'm going to put this in my calculator. So I'm going to go 1,000 divided by, over 100. And then I'm going to multiply by 5. And I get 50. And our volume is going to be in milliliters, because volume is often in milliliters. So the volume that's required for this patient is 50 milliliters per 50 milliliters. Excuse me, I was just about to sneeze and I still might. Now, what we have here is dosage for children. You will be asked to use these, but you're not asked to remember them. Okay, so it's just that we're going to be using these. So there's the 3 ones. There's Fry's formula. I'm sure that you say it very differently to what I just said. Young's formula and Clark's formula, okay? And it's really clear how we use it. It's age in months, adult dosage, and then a number. So age of a child in years, adult dosage, and the age of the child plus 12. So let's go with an example that covers this. So here, what I've done is that I've copied and pasted the last slide into here so it will help us. All right, example 3. As Young's rule, use Young's rule to find the required dose for an 8-year-old child, if the adult dosage 10 mils. So it asks us to use Young's formula. And do we fit in the category of 1 to 12 years? Yes, 8-year-old child is one of them. So let's do this. Equals, and we're going to use this. So what's the age of the child in years? Here we are, 8. So I'm looking at that first, and I'm going to multiply by the adult dosage. And the adult dosage is 10 mils. So I'm going to go times 10 over the age of the child plus 12. So I'm going to go 8 plus 12. Now I'm going to pop that into my calculator, and that is 8 times 10 over 8 plus 12. And the answer here is 4. All right. So what will the dosage be? It will be 4 milliliters, which is clearly less than the 10 mils that's required for an adult. So we can be asked to use any of these formulas to calculate a dosage for a child. But remember, you will be given these if you're asked to do it. Now, that's the end of the lesson for today. So, peace out.